This is Geometry Chapter 4, Section 3, in which we will study congruent triangles. Whenever we're talking about geometric figures, triangles, squares, rectangles, trapezoids, hexagons, whatever, any kind of figures that are exactly the same size and they're exactly the same shape, we call those congruent figures. Okay. And when we have congruent polygons, all of the parts of one polygon are congruent to what they call the corresponding parts of the other. Right, you're already familiar with the idea of corresponding from corresponding angles in the last chapter. The ones that match up with each other. In polygons, some of the sides will match up with each other, and those sides are congruent to one another. Same thing with angles, some of the angles will match up. So what we're looking at here, and specifically talking about triangles, we need to identify the corresponding parts here. And then we'll write a congruent statement. Okay. Clearly these are the same triangle, right? I mean, you can see it. I superimpose one on top of the other. But we'll put it back over there so we can work with it. So which angles match up? Angle X is in the same place as angle P. Angle Z is in the same place as angle R, and angle Y is in the same as angle Q. So those angles are corresponding to each other. What about sides? We can say that side XY matches side PQ. Side YZ matches side QR. And side RP matches up with side ZX. When they ask you to identify the congruent corresponding parts, that's what they're talking about doing. You're going to have 6 pieces when we're talking triangles. 3 angle statements and 3 segment statements. And then they want us to write a congruent statement. Well, when we name a pair of congruent triangles, the order of the letters is vital. It's very important to have the orders correct. Now, for one triangle, you can name in any order you want to. So I chose to call this triangle XYZ. I can name the first one any way I want to, but when I name the second one, it has to match. X matched P, so X has to match P. X went first, P goes first. Y matched Q, Y was in the middle, so Q has to be in the middle. Z matched R, Z was last, R has to be last. Your first one, you pick the order. The second one, the order is dictated by who matched up. Now, when you do your congruent statements here, you don't have to do it in multicolor like I did. I just wanted to make sure you could see why the letters were in the same orders, or why they're in the order that I put them in, so you could see that they matched. Now we can use this idea of congruency in a whole different direction. Okay, we've got 2 triangles, triangle ABC and triangle DFE. And they tell me that those 2 triangles are congruent to each other. Our job is to figure out values for X and for Y. Okay. First thing we need to do is figure out what matches up with what. Angle E, because I have a value for angle E over here. angle E matches one of these three angles. The question is which one? E is last, so is C. So E has to match C. Okay. 8y minus 5 equals 99. Add the 5 over and divide, and we find out y is 13. Okay. Segment DF, because we have a value associated with that, matches one of these three sides. DF is the first and middle, so it would have to match AB. So 2y plus x is equal to 54. Well, we know what y is. Y is 13. We figured that out over here, so we can substitute that in. Do a little multiplication and then a little subtraction, and we find out what x is, 28. The other values, the 45 degrees, the 36 degrees, and these two sides, were there as distractors. Okay, don't fall for it. Use the one that matches up, and you can't go wrong. Okay. Now we have this new idea here called the third angles theorem. Okay, and it's got a whole lot of prepositional phrases, but don't let that tangle you up. The idea is something fairly straightforward. If two angles in one triangle are congruent to two angles in the second triangle, then we can say that the third angles of each triangle are also congruent. Okay. And we're going to do this one. There's several different ways we could prove it, but since we've got this beautiful picture here, we're going to go with this one. So they're going to tell me that I have all this nice information. Actually, we're not proving this theorem, we're proving something about this triangle. We're going to use this theorem to get there. So we're told that DE matches GE, DF matches GF, angle D matches angle G, and then angle DFE is equal to angle GFE. We're given all of that. And our job is to prove that means we have two congruent triangles. Okay? We can do that. We have the skills. Remember what we know about congruent triangles. They have three sets of equal sides and three sets of equal angles. Well, I've got two sets of equal sides. I need one more. Which side is in this first in triangle DEF that we haven't talked about? Side EF. Now here's a trick question. Which side in triangle GEF have we not talked about? Side EF. I'm sure you'll agree with me that EF is congruent to itself. And that's one that we really like, reflexive property. This is one of the few places where we have to use reflexive because we have to establish that we have the right number of sides to work from. Now we also need three sets of congruent angles. We've got two. So the third angle theorem tells me this third angle, DEF, is the same size as GEF. That's the third angle theorem. You'll notice sometimes I go singular and sometimes I go plural. Doesn't matter really. Well, now we have everything we need. We have three sets of matching sides. We have three sets of matching angles. So we can say that the triangles are indeed congruent because of the definition of congruent triangles. Remember, the definition said that the sides are equal and all the angles are equal, the corresponding ones. Okay. One last theorem to throw at you. And that theorem is theorem 4.4, and it's one similar to a couple of theorems we've had before. Okay. When we've talked about angles and we talked about segments before, we said the reflexive property still works, the symmetric property still works, and the transitive property still works. And that also is true when we're talking about triangle congruence. A triangle is congruent to itself. I can switch sides of the equation, and I can use the transitive or the substitution property. That's all that theorem is telling you, is that things that you know to be true for numbers, for segments, and for angles also work for congruent triangles. Okay. As always, if you had questions along the way, hopefully you wrote those down. Bring them in with you, and we will see you in class.